we'll talk about more about the area under the curve later in the exercise. Now we just focus on pure calculation. So how do we calculate that one? We try to find the integral from pi over 2 to 3 pi over 4 for 4 cosine 2x over 3. Okay, so cosine will become what if you integral cosine? Positive sign. And you have coefficient of 2 over 3x in the bracket. Therefore, you will times the 3 over 2 outside. Because it's 1 over that value, you flip it. And cosine will become sine. And you still have 2x over 3 here. And you will have pi over 2 to 3 pi over 4. You don't need to plus c in this case. Okay, and can you see there's a constant, like the constant is 6. So you can put the 6 outside the square bracket. Half bracket, pi over 2 and 3 pi over 4. Like that. The 6 can leave out first. And then you can calculate. As I said, you will substitute the top number first. That becomes sine, well, 2 over 3 times 3 pi over 4. Okay, subtract sine 2 over 3 times pi over 2. Okay, you sub them individually and you subtract, use the larger one, subtract the lower one. Not the larger one. Sometimes it's not necessary to be large numbers on the top. You just use the top number, subtract the bottom number. So that you will have sine, okay. When I have 3 and 3 just gone, that become a 2, that gone, just pi over 2. Minus sine pi over 3. That 2 cancel, just pi over 3. And the 6 is still outside the bracket. 6 is a factor. Okay, 6 is a factor times the whole difference. So what is sine pi over 2? What's sine pi over 2? 1. Okay. Sine pi over 3. Root 3 over 2. Okay, so you can leave your answer like that or you can expand that. Like I would like to expand it. 6 minus 3 root 3. Well, both ways correct. Okay, like you can leave the factorized form or you can do the expansion form. Okay, next one. Next one is exponential. Next one is exponential. Okay, exponential. You have negative a half for the common factor. So you times negative 2 in the front. You have negative 6 e to the power of negative x over 2 plus. Okay, 3 on the top is a 4 over 3, e 3x. You would divide by the factor. Okay, divide by the factor of x. And then you will use a square bracket. Okay, make sure you use square bracket in this case. Have a minus 2 and have a 2. Okay, if you can't do it like really quick at the beginning, just make sure you substitute like clearly and show the difference between two functions. So that is negative 2e to the power of negative 1 plus 4 over 3 e to the power of 6. Okay, that is when you x equals to 2. Okay, that is one thing. Subtract, you sub negative 2 in this case. Negative 6 e to the power of 1 plus 4 over 3 e to the power of -6. That is minus, well, that is -6 over e plus 4e to the power of 6 over 3 plus 6 to the power of e minus 4 over 3e to the power of 6. Well, you can't do much to it. You can leave your answer like that. Okay, next one. What's this integral will be? Like give me the name of the function, like polynomials or exponential or what is it? Log. Okay, it should be a log. Because there's a linear and the denominator, you have a power of -1, so that must be a log. So if that's a log, you should have, okay, the bottom is 4x plus 7 already. Then the top, what you need should be a 4. Okay, what you need should be 4. G dash x over gx, that's log. Okay, you need g dash x on the top. That is gx. That is g dash x. And don't forget, you have a 3 as well. The 3 will put outside. And you times the 4 onto this function, which is not making sense. You need to divide the 4 as well. So that is still a 3. Okay, 3 over 4 times 4, that's still a 3. And it can make g dash x to gx form. And the x. Don't forget the upper limit and lower limit, which is -1 to 3. Therefore, I have 3 over 4, okay, log e absolute 4x plus 7, absolute, square bracket, -1 to 3. Okay, the 3 over 4 is the coefficient, leave outside, and what you have is log e, 12 plus 7 is 19, minus log e, -1 put in, -4 plus 7, you have 3, finish the bracket, that's a 3 over 4 log e bracket, 19 over 3, 19 over 3. Subtract between log can be divided by the number inside. Okay, divide the number inside. Okay. Okay, now we start to talk about some properties about this kind of equation. So what kind of properties you will have? Okay, it's talking about the area under the curve. It's talking about the area under the curve. And let's have a think. If you have terminus A to A, okay, you have value A to A. Basically, you have no area. Can you think about that? Like, same point to same point. There's no area. You're not making any area. It's just a vertical line. It's like a two-dimensional thing. Like, just have a line. Okay, so there's no area. So the area will be 0. So basically, you have, for example, 1 to 1 fx dx. That is just 0. There's no value for that. There's no value for that. Okay. The next one is talk about if the graph of f is symmetrical about the y-axis, then the negative a to a fx will be 2 lots of 0 to a. This is like reduce the difficulty for calculations. Like you put negative a and a in will be quite hard to calculate. But you put 0 to a, like something involves 0, will easy to calculate. So let's do the example will be, let's say x squared. Let's just say x squared. I want to integral x squared from 3 to -3 to 3. Well, x squared looks like this. It looks like that. It's symmetrical about the y-axis. If you say the area from -3 to 3, you talk about this area and this area. Okay, the left-hand side area should equals to the right-hand side area. Okay, left-hand side area should equals to right-hand side area. Therefore, this can be say as 0 to 3, 2 logs of 0 to 3x squared dx. Okay, the restriction is the graph must be symmetrical about the y-axis, and the value must be negative of a and a. Okay, it's symmetrical points as well. Symmetrical points as well. That's the second property. The third one, we just keep using it. Like the k can be moved out as well. Like doesn't matter whether it's an indefinite integral or definite integral. The k can always go out of the sign of integral. A constant. Okay, x cannot go outside. Only the constant. And same for if you sub or add two functions. If you add or sub two functions, you will do that separately with the same like upper limit and lower limit. Okay, separating two functions and with the same upper and lower limit. Doesn't matter it's an add or subtraction. But times and division, you can't do that. Okay, times and divide, you can't do that. Only add or subtract. Okay, next one is a really interesting one. If you go for fx plus c, like you add some function fx and then you plus c, you plus the c value. That is same as you integral fx from a to b plus you integral c from a to b. What's the integral of a constant? What's the integral of c? Cx. So you will have cx for this one. You have cx for the second one, and you have a to b. So when you sub b in, that equals to cb. When you sub a in, that will equals to ca. So therefore, that's cb minus a, okay, which is this one. So you can evaluate the constant part first and leave the fx. I will show you why we need to know this. There will be some examples combined with those properties. All right, next one. A, B, fx, that. Okay, well, I make a mistake here. I need to change the terminus BA. Change here, B to A. Well, if I change the upper limit and lower limit, I swap the place for them, that will be a negative of the area. Okay, it will be negative of that area. If I flip the upper and lower limit, you put a negative sign in front. That will be equals to negative of that. A to C, C to B. Okay, have a look at the next one. If we talk about the area between A to B, we can say we find the area from A to C first, and then we add the area from C to B. Does that make sense? Like say we have a graph like that. Can go below a little bit, like that. And originally I want to find the area from say A to B. Well, I can find a point C in between A and B. And I can say I want to find the area from A to C first, and then I want to find the area from C to B and add them. So A to B first, A to C first, and then C to B. So this and this are the same. Okay, those two values can combine together, and that whole thing can become integral of A to B fx. Okay, so that's the basic properties we need to use. Let's have a look at example 12. Let's have a look at example 12. Okay, in example 12, it says integral 2 to 6 fx dx equals to m. I'll give you a value of m. I'll let you know that you don't know fx, but you know that you integral that function from 2 to 6, you have a value of m. The area under the curve from 2 to 6 is m. And same thing, the area under the curve gx from 3 to 5 gives you p. Okay, find the following in terms of M or P or both. Okay, the first one, we have that. And this will be 3 times 2 to 6 fx dx. That gives me 3m. This one will be 4 times 3 to 5 gx dx minus 4 integral 2 to 6 fx dx. That equals to 4p minus 4m. Have a think about the next one. Okay, the next one you can see that's 2 to 3 and then 3 to 6. I can say that's directly 2 to 6 of fx dx, and that equals to m. Okay, and the next one will be, okay, next one, have a look at next one. Something, subtract something. I can say that 6 to 2, 4 dx minus 2 integral 6 to 2 of fx dx. The integral 4 will become 4x, then 6 to 2. And this is 6 to 2. I want 2 to 6. I have 2 to 6. Okay, m equals to 2 to 6 of fx. So that's minus 2. That can become a minus 2 to 6 fx dx. I can change the upper limit and lower limit, and then that will still be the same. Put a negative sign in the front. So that is 4 times 2 minus 6. Well, you sub 2 in, subtract when you sub 6 in. That's a plus 2 integral 2 6 fx dx. What's that? That's minus 4 times 4 minus 16 plus 2m. Okay, I want you to put one question here. This is a really good question from Vika, like not exactly the same, but like very similar. Let's say the E, part E. So the question will be integral of f, small f is the same f as before, 3x minus 6. 3x minus 6 and dx, and the determinant is, let me have a look what we have before. We have 2 and 6. So 2 plus 6 is, 2 plus 6 is 8. 8 y squared, that's 8 over 3. And the next one you have 12, well, that's 4. Let's do this. That's 8 over 3. Okay, let's have a think how to do this question. This is a hard question, but it's like a Vika really like to put this kind of question in the multiple choice or short answer. So 3x minus 6. This f is still the same f of this one. And then the terminus has been changed as well. It's not 2 to 6. Well, it must be changed. If it's not changing, that's wrong. Have a think about, okay, compare this f function and this fx function. What kind of translation or transformation has been applied? Like how fx become this? Just let me know that. How fx become that? There must be a dilation and a translation. Well, there might not have no reflection. What has been done? What's the dilation factor? A third. What's the translation? Translation to which direction? Well, if you say translation first, that might be 6. But if you say dilation first, then the translation can't be 6. Okay, so what we need to do is x equals to 3x dash minus 6. Then x plus 6 over 3 equals to x dash. X dash equals to a third x plus 2. So this graph has been, okay, it's changing x value. It actually has been changed this direction. Okay, changing in this direction. Okay, compressed in. And then move to the right. Okay, move to the right. Before we do this question, let's think about easier one. So if we say integral of fx plus like minus 2 dx, and then the terminus is 4 to 8. What do you think this will be? Okay, I'll say you have fx looks like that. Say you have fx looks like that. And then from 2 to 6 is before. Okay, 2 to 6, you have the area of M. What has been done for fx minus 2? Shift to which direction? Right or left? Right. Okay, shift right for 2 units. So the whole graph has been shifted by 2 units to the right. So basically you will have like something like that. But the good thing is your upper limit and lower limit has been shifted at the same time 2 units to that direction. So that become 4 to 8. But it still refers to the same area. Does that make sense? The whole graph has been shifted, and your upper and lower limit has been shifted together with the graph, so the area doesn't change. Therefore, if you shift your graph left or right with the same, like upper or lower limit shift together, you won't change your area of the graph. So that area is still equals to M. That area is still equal to M. That's still the original area. That is equivalent to say that's 2 to 6 fx dx equals to M. Because everything has been shifted by 2 units, the graph won't change. But have a think about dilation. If you have dilate your graph, even though you dilate your upper and lower limit at the same time, do you think the graph will change area or not? Do you think the area will reduce or increase if you stretch the graph? Yes. Okay, the area, the shape has been changed. If you just stretch it, the area can become larger, even though you shift your terminus. Like, think about there's a graph looks like that now, and then you stretch it. The area under the curve must be like changed as well. Okay, so that's for general thinking what should be done for this question. But let's think about algebraic way to do this. First, you need to understand if there's a translation, just translation happens, the area won't change. That's the first thing you need to know. And the second thing you need to know is if there's a dilation, even though you dilate your terminus at the same time, the graph's area still change. Okay, so this question I asked, 1 equals to M, 1 equals to M. That will be a factor of M, like a third of M or 3 of M. Okay, I will let you know that the answer will either be 3m or a third of m. Because I can ignore the translation, doesn't matter. But I must take the dilation into consideration. So it's either a third or 3. Let's have a think. Let's have a think. Okay, you need to follow me here, okay? So let's have a think about the original equation. Original equation. Integral of 2 to 6 fx dx. Okay, let's say that is capital Fx after I integral that. The integral is like antiderive is capital F 2 to 6. Okay, and that's F6 minus F2. Capital F6 minus capital F2 equals to M. That's what you have now. Okay, what do you think the integral of that will become? The integral of that will become something capital F 3x minus 6. Well, the lowercase f will become uppercase f. Therefore, integral of that will become this as well. But let's have a think about this. If you dx this, what do you have? Well, let's put this here. If you dx capital F 3x minus 6, what you will have? What that equals to? By using chain rule. What's the derivative of that? 3. Yeah. And? Yeah. The upper f will become lowercase f. Well, g dash x, f dash gx, right? G dash x, you integral the inside, like differentiate inside, differentiate the outside function, and you still have this inside. You will have that. Okay, if you differentiate that, you will have that. Therefore, if you anti-differentiate that, you will go back to capital F. Is that correct? Yes. So now, instead of integral this, what I want to do is a third. 3 lowercase f 3x minus 6. Why I'm doing that? Because I want to make the same form as this one in order to antiderive. A third times 3 will become 1. That still looks the same as beginning. But I can have a third capital F bracket 3x minus 6 inside now. And that's 8 over 3 to 4. That is a third. Okay, I sub 4 in. That gives me minus F6. Minus, I sub that in. That gives me F2. What's F6 minus F2? That's M. F6 minus F2 is M. That's what you figure out from beginning. So that gives you a third of M. Okay, that will give you a third of M. If that's a short answer, you need to write all of this down. Okay? Like that's number 1, what you need to do, that's number 2, and that's number 3. Have a think about this. It's quite hard to think about. Well, like if I'm not doing this here, when you do the final exam, you will feel like this question is like no way to solve. Okay? So you can think about 2 ways. The first way is dilation. Because there's dilation by a third, the area must be reduced by a third as well. Okay? That's the first way you think it. Second is by like numerical proof. Okay, that's the proof steps, and that show why that is a third of the original area. You need chain rule here. That's quite important. Any questions about this? Any questions about this? Okay, if no, let's come back to this one. Given that 2 to k of that equals to 7, find the value of k. Find the value of k. Well, let's just take that away. I'll put number 1 here. Okay. Given that equals to 7, find the value of k. So for this one, that is a log e 2x plus 5. That is a log e 2x plus 5. Again, gx and at the bottom, g dash x on the top. What you put is 2 to k. That equals to 7. So log e 2k plus 5 minus log e of 9. That equals to 7. Okay, so log e 2k plus 5 equals to, okay, 7. 7 is log e to the power of 7 plus log e 9. Log e 2k plus 5 equals to log e 9e to the power of 7. You can times them together. 2k plus 5 equals to 9e to the power of 7. K equals to 9e to the power of 7 minus 5 divided by 2. Okay, let's assume 2k plus 5 greater than 0 here. 2k, well, it should give you k greater than 0 in this question because the new study design does not include absolute sign in it, so we shouldn't take this like into consideration. If you learn Spec, you know what I'm talking about. But like in this case, we just assume k is a positive number and we just solve it normally. We shouldn't solve the negative one as well. Well, give you additional thing is k greater than 0 in this case. And therefore, 2k plus 5 will be greater than 0, and that will become a lower bracket, a smaller bracket. Okay. Okay, just go through a little bit for that. Well, no, I'm not going to talk about this today. I will make sure you take your calculator tomorrow. Okay, take your calculator tomorrow, and I want to find the sign with you tomorrow. Okay? We have class tomorrow, right? Yeah, okay. We won't have class on Thursday, next Thursday. It's beyond BCE.